Good morning children, welcome to online physical science classes. This is 8th standard online physical science class and today we are going to start the new unit in chemistry lesson 6 chemical reactions. We all know that all reactions are accompanied by a change in energy. Am I right children? By a change in energy, and energy is either given out or taken in during a chemical reaction. If a chemical reaction in which heat or light is evolved means given out is called exothermic reaction, and a chemical reaction in which heat or light is absorbed is called an endothermic reaction. But why a change in energy in a chemical reaction? Why a change in energy in a chemical reaction happens? As we know, any two atoms in the molecules are held together by a force of attraction called chemical bond, right? And also that a chemical bond is much stronger than an intermolecular force. We also know that that is the atom that take part in a chemical reaction. Thus, we can consider a chemical reaction to be a result of the following phenomena: the breaking of bonds of the reactant molecules so as to set the atoms free for new combination. So, the bond should be broken so that a new combination is possible. The forming of fresh bonds between the new partners so that the product molecules are formed. So the energy required for the breaking of the bonds of the reactant molecule is not the same as that given out in the formation of bonds between the new partners. So the same amount of energy is not required for both the process. Okay. When the energy given out in the formation of the bond is more than that used for breaking of the bond, the surplus energy evolved and the process is exothermic. So when the energy given out in the formation during the formation of bonds, so breaking the bonds, and that surplus means high amount of energy is evolved, is given out. So such reactions are called exothermic reactions. Is it clear for you? I hope you have understood this process. Yes. However, when the energy required for the breaking of bonds is greater than that given out in the formation of bonds, the energy difference has to be compensated for from outside. In other words, energy will be absorbed from the surroundings for the reactions to happen. Okay, and the process is called endothermic. So this is what actually happening in the case of chemical reactions. Okay children, see, to break the bond between A and A, some energy has to be absorbed from the surrounding. Okay, and between B and B, some energy has to be absorbed. And while forming a new bond between A and B, some surplus, more amount of energy is released. Okay, so taking in the energy is taken taken in, no, that is called endothermic. Endo. Okay, and energy is given out, so that is called as exothermic. Do you understood this exothermic and endothermic reaction? Let us discuss some examples of exothermic reactions. First, burning is a best exothermic reaction, and this burning, for example, hydrogen combines with oxygen to form water, carbon combines with oxygen to form carbon dioxide, methane, cng gases, that is fuels, no, cng gases, and they combine with the oxygen, that is burns with the oxygen. In the presence of oxygen they form carbon dioxide and water molecules. LPG gases, methane gas, that reacts with or burns in the presence of oxygen to form carbon dioxide and water molecules. So all these burning process are exothermic process, that is heat is given out. The next one is how some active metals react with the water. And the third process is dissolution of metal oxides, that is bases in water. Bases, when the dissolution in water, they form, during that reaction heat energy is evolved. For example, sodium oxide Na2, when it dissolved in water, it forms sodium hydroxide. During that process heat will be evolved. And dissolution of non-metal oxides, that is non-metal oxides are acidic in nature. When they are dissolved in water, that also emits the heat energy. For example, carbon dioxide, when reacts with or dissolved with water, it forms carbonic acid. So during this process, heat energy is released. Similarly, the reaction between basic and acidic oxides. Reaction between basic and acidic oxides, CaCO, calcium oxide, that is a basic oxide, and CO2, carbon dioxide, is acidic acid. When they react, they form calcium carbonate. So during this process also heat is evolved. Neutralization reactions. The next one is neutralization reaction. In neutralization reaction, acid reacts with a base forming salt and water. All these reactions are exothermic reactions. For example, sodium hydroxide, which is a base, and HCl, that is hydrogen chloride, is an acid. They react to form NaCl, salt, and water, H2O. Okay, children. So this is about neutralization. Neutralization means converting the acidic and basic nature into a neutral mode. That is neutralization reaction. All these reactions are exothermic reaction. And the next type of example of exothermic reaction is reaction of an acid with a metal carbonate. If an acid reacts with metal carbonate, then it can perform. For example, when acid acts on carbonate or hydrogen carbonate producing carbon dioxide. This reaction is also an exothermic reaction. For example, sodium carbonate reacts with a hydrogen chloride. It forms sodium chloride plus water and carbon dioxide. Carbon dioxide is evolved in these cases. So evaluation of carbon dioxide always accompanied with the heat energy evaluation. Okay. The next one is respiration. Respiration, you know that it happens in all the living beings. So what's the reaction? Actually, glucose, C6H12O6 is the glucose. When it reacts with oxygen, the intake oxygen, it forms carbon dioxide. We are giving out the carbon dioxide, no, carbon dioxide and water molecules. This is also an exothermic reaction. That is how we feel warm when we walk fastly or run fastly or work out anything very hardly. Okay, children. So these are some examples. And finally, rusting. You know, rusting is also an example of exothermic reaction. Though it is a simple, it is an exothermic reaction, but we can't feel the evaluation of heat, but heat is evolved there. Okay. So iron, when reacts with water and moisture, it forms rust. The formula for rust is Fe2O3.X H2O. Okay. Yes. So this is about the examples of exothermic reaction. Now we are going to learn about the examples of endothermic reactions. Endothermic reactions, when a combination of nitrogen with oxygen. So when nitrogen combines with oxygen, mostly this type of reactions are endothermic reactions. So nitrogen, when reacts with oxygen, the presence of, when an electric spark is passed through the mixture of these two gases, the reaction, what is the product form? Nitric oxide will be NO. Nitric oxide will be formed, and this is an endothermic reaction. That is, heat is absorbed from the surrounding. Heat is absorbed from the surrounding. Okay, next one is thermal decomposition of metal carbonates. Okay, what is thermal decomposition? The breaking down of a substance into a simpler substance on being heated is called thermal decomposition. So when you supply heat, because of the heat, if the decomposition, that is decomposition means breaking takes place, means that is called thermal decomposition. So metal carbonates are decomposed or heated. They decompose to form oxides. So this reaction also involves the absorption of heat energy. Example, magnesium carbonate, when it is heated, magnesium oxide and carbon dioxide will be formed. The reaction is an endothermic reaction. And under photosynthesis, the next type of reaction is photosynthesis. Photosynthesis, you know that it is the absorption of sunlight, isn't it? Without sunlight, photosynthesis is not possible. So absorption of sunlight. So for absorption of sunlight, so this reaction is also an since the energy is absorbed, so this reaction is also an endothermic reaction. Okay, then endothermic reactions. Endothermic reactions are a physical process. Endothermic reactions are mostly physical process. See, for melting of ice, converting the water into water vapor, all these are endothermic reaction, and these are all physical process. Similarly, the dissolution of ammonium chloride, ammonium nitrate, or glucose in water are also some common examples. See, when you put some glucose on your tongue, you will feel the chillness. This is due to the absorption of heat energy from the surroundings, so that you feel the chillness. Okay, these are all some common examples. So endothermic process or physical processes. Okay, some common observation. What are the common observation we can see? Exothermic reactions are common than endothermic reactions. Okay, exothermic is present very commonly, but not as endothermic. Once they begin, exothermic reaction continue on their own, but endothermic reaction do not. So exothermic reaction, when it started, it will continue. So for example, when you burn the paper, the burning will continue and it ends till the paper fully get burned. But endothermic process is not like that. Okay, then most exothermic reactions to have to be initiated. Exothermic reactions also have to be initiated. This we will discuss in our higher classes. The next one is type of chemical reactions. So the first type of reaction is combination reaction. Combination reaction. In a combination reaction, when two or more substances add up to form a product, then the reaction is called a combination reaction. Okay. So look at this example here. Hydrogen combines with oxygen to form water. Two or more reactants combine to form the product, that is called combination reaction. Do you understood this? And also some some carbon dioxide gas is passed through the lime water, it will form a milky white precipitate. That is also an example for combination reaction. And when you burn the magnesium ribbon in open jar, the magnesium ribbon forms will continue to burn and forms a white smoky solid on the walls of that open jar, and that is magnesium combines with oxygen to form that white solid. So it is a best example for combination reaction. Is it clear? Rusting is also a combination reaction. The next type of reactions we are going to discuss is decomposition reaction. Decomposition reactions are the reactions in one substances break down into two or more simpler substances. Okay, one will be break down into two or more substances. The best example is decomposition of water on electrolysis. So electrolysis of water, take some water mixed with a few drops of dilute sulfuric acid in a beaker. Okay, and invert two test tubes test tubes full of water into it. Remove the insulations from the end of the two thick wires. Introduce them into the insulation, means that plastic wraps around the wire, that has to be removed, and introduce them into the test tube as shown in the figure. Okay, like this you have to insert the wires and connect the wires to a battery and pass a current. So this should be connected to the battery and current should be passed for some time. Gases start collecting in the test tube. So while passing the current, we may notice some gases are getting collected in the inverted test tube at the empty space. You will observe that the volume of the gas collected over the negative electrode no, is twice that of the gas collected over the positive. Look at here almost empty, but here only up to this level only the gas is collected. Okay, so almost twice that. Okay, then so stop passing the current when there is enough gas in the test tubes. Cork the test tubes inside the water and take them out. Perform the following experiment. So then you have to verify what gas it is. So what you have to do, you have to bring a lighted match near the mouth of the test tube and open its mouth, the gas burns with a pop sound. So it is a hydrogen. For that, the negative electrode, this test tube, no, the mouth of the near the mouth of this test tube, you have to show some what matchstick, so that it will burn with a pop sound, so that we can confirm that it is an hydrogen gas. Then for this negative positive electrode, this test tube, for this test tube, what you have to do, you have to bring a glowing matchstick near the mouth of the test tube and remove the cork. The matchstick get lighted, so the gas is oxygen. So oxygen, you know that oxygen helps for burning, so we can confirm it is oxygen. From this we can conclude that the volume ratio of hydrogen and oxygen in water is 2:1. So almost 2% of hydrogen and 1% of oxygen is collected through the electrolysis of water. Do you understand? Yes. Decomposition of baking soda, that is sodium hydrogen carbonate, NaHCO3 is baking soda. You know baking soda now, that is used in our day-to-day life. That is when it is heated, it becomes sodium carbonate, Na2CO3, water vapor, and water vapor and carbon dioxide also formed. So this decomposition, it's an example for decomposition reaction. The next decomposition reaction is potassium chloride on being heated. What happens? Potassium chloride will be formed under oxygen also. So one molecule broke down into two simple molecules, then we call it as decomposition reaction. Do you understood what are decomposition reaction? Hope you have understood well. Okay, now displacement reactions. Displacement reactions are very simple reactions. One element displaces another from its compound and take its place therein. That is the displacement reaction. Let us discuss how. See, look at these example. Potassium reacts with water to form potassium hydroxide and water. See, what happened there? The place of OH in water, the place of OH is replaced by, or the place of OH is replaced by the is taken by this potassium. Okay, so H2 place, hydrogen's place is replaced by potassium, so that KOH is formed. Similarly, hydrogen place is replaced by sodium. Instead of hydrogen, what combines with OH here? The sodium combines, so NaOH is formed. So one element replaces another element, that is called displacement reaction. We understood, children? So here are some examples. The magnesium ribbon burns in steam. When it burns in steam, what happens? Magnesium atom displaces two hydrogen atoms and takes their place. See, this is what happens in this reaction. Okay, magnesium replaces the hydrogen place and it forms magnesium oxide. Okay, do you understood? So the process is this. Here is another example. When iron is placed in copper sulfate solution, it forms copper brown red. Under ferrous sulfate, copper which is brown red in color, and ferrous sulfate will be formed. Look at the equation. See, iron which it replaces the place of sulfate. Okay, iron, it replaces the place of copper. Instead of copper, iron place comes there, so FeSO4 is formed. Do you understood, children? And this is the so this is a displacement. Instead of one element, another element displaces. Do you understood this fact? Yes. Okay, now the next type of reaction is double displacement reaction. In this reactions, two elements will be replace their places. Okay, will displace their places. For example, silver nitrate, which is colorless, reacts with sodium chloride, which is also colorless. They form silver nitrate, which is white in color. So silver nitrate should be taken in test tube and the sodium chloride has to be added. Both are colorless, but when you add sodium chloride, it forms a white colored precipitate. A precipitate is like this only. Okay, so a precipitate is like this only. So this can be seen, and this is because what happening there, because of the formation of silver chloride. Okay, silver chloride, look at the equation. So here, so silver replaces the sodium. Okay, here they are interchanged, they get interchanged. So silver reacts, combines with the chlorine to form silver chloride, they understood. And sodium replaces silver, and it combines with the nitrate to form sodium nitrate. Okay children, do you understood? So double displacement is taken, two elements displaces there, so that is called double displacement reaction. Hope you have understood today's class very well children. We will meet in the next class. Until then, complete your assignment and report in the group. Similarly, prepare well for the upcoming class exam children. Thank you.